Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in the subject electrical and electronics engineering. We're going to see the principle and working of half-wave rectifier in this video. In previous video we have already seen the working of PN junction diode, and today we're going to see about rectifiers, which is one of the application of a PN junction diode, right? So we already know that a diode conducts electricity in one direction, and whereas it does not conduct in the reverse direction, right? Based upon this principle, a PN junction diode can be used as a rectifier, right? And this rectifiers can be classified into half-wave rectifier and full-wave rectifier. First, you have to understand what is a rectifier. So rectifier is an electronic device which converts an AC current to a DC current, or an AC voltage to a pulsating DC. So you can see here, if you want to apply any AC waveform, that is an alternating current, right, AC, right? So you'll have a positive and as well as negative, right? And this is AC, which can be converted into a pulsating DC, right, through rectifier. So rectifier is a device that converts an AC to a pulsating DC, right? So in this rectifier we have half-wave rectifier and full-wave rectifier. What is it by half-wave rectifier? That is, if it rectifies one cycle, either a positive cycle or negative cycle, if it rectifies only one half cycle of an AC, right, then that is called as half-wave rectifier. Whereas if it rectifies both positive and as well as negative cycle, then that is called as full wave rectifier. In this video, we will see half wave rectifier. We will see the working of half-wave rectifier, the characteristics, advantages and applications of half-wave rectifier. And as I said, rectifier is a device, electronic device that converts an AC voltage to a DC voltage, an AC current to a DC current, right? And if you see here, right, this is the normal AC voltage, right, AC voltage waveform, right? It is converted to a pulsating DC, whereas in only one half cycle, that is why it is called as half wave rectifier. So how does it happens? As I said, this rectifier works in the principle of diode, PN junction diode. We know that in PN junction diode, current conduction will take place in one direction, that is when it is forward biased, and it will not conduct during reverse biased, right? So if it conducts, it allows this input cycle, the input voltage to flow through, and if it does not conduct, it will block the input voltage, right? So this is the construction of half-wave rectifier, where for the construction we will have a transformer, a load resistance and a diode, a PN junction diode, right? And this is a normal transformer, right? Whenever you give an AC input, right, and that AC input, which is the positive cycle, like whenever you supply a positive, the AC input to this transformer, during the positive cycle of this AC input, this terminal, the anode of this particular diode will be forward biased, right, and it will conduct. So it will allow the complete AC voltage, the complete positive cycle to flow through this particular RL, right, and that is why we get this particular waveform. And during negative cycle, what happens? Negative cycle, this anode will become reverse biased, right? If you're going to supply a negative voltage here, it becomes reverse biased, and this will act as an open switch. So which means it will not allow the current to flow through, right? So there will not be any conduction will happen, because there will not be any flow of voltage or current across RL. So there will not be any conduction during negative half cycle, right? This is the working of half wave rectifier. Just by using a single transformer and a diode, we can able to design an half-wave rectifier. And the reason why it is called as half-wave rectifier, it conducts only during one half of the cycle. It can be either positive half cycle or negative half cycle, right, depending upon the construction of that particular rectifier, right? And whatever I said, that is what I explained here. During positive half cycle, the anode of the diode become positive, right, and it conducts, whereas in the negative half cycle it becomes negative and it will not conduct. And you can see here the same diagram, right, where a complete AC voltage is converted to a pulsating DC, but here the efficiency is only around 40% because it conducts only during positive half cycle, right? Now we'll see the characteristics of a rectifier. The very important characteristic of a rectifier is ripple factor. What is ripple factor? During this conversion from AC to a pulsating DC, right, there will be some distortion, there will be some oscillation in this particular output, right, and that particular oscillation is called as ripples. And a ripple factor is one which tells you the number of ripples which is present in the DC, right? So in off-wave rectifier, the ripple factor will be very high. That's because it conducts only during one cycle. There will be a lot of distortions, right? There will be more ripple factor, more ripples, right? And a ripple factor is the one which tells you the number of ripples in the output voltage. And it can be defined as ratio of RMS value of AC component of the output voltage to the DC component of the output voltage, right? And it can be denoted as gamma, where this is the formula for ripple factor, right? And the very important characteristic is DC current, where DC current here is the maximum DC load current divided by pi. And similarly, DC output voltage, it can be denoted as Vx max divided by pi. Another important factor is form factor. The form factor of half-wave rectifier is more. The form factor is the ratio of RMS value to the DC value, right? And the form factor is 1.57, whereas the efficiency of rectifier, the efficiency of half-wave rectifier is around 40.6. That's because it is conducts only during positive half cycle, right? That is the rectifier efficiency can also be called as ratio of output DC power to the input AC power, right? And coming to advantages of rectifier, it is very simple, right? The connections is very simple and it is very low cost, right? And it is easy to connect, and number of components used is very less. Whereas the disadvantages, the ripple factor is more, which means there will be more ripples, right? The DC will not be a smooth DC, it will have more ripples. So the ripple factor is more, and because of that harmonics will get generated, and utilization of transformer is very low. That's because we conduct only in one half cycle, and efficiency of rectification is very low. These are the disadvantages of half-wave rectifier. Coming to applications of half-wave rectifier, it can be used as a power rectifier, where it can be used along with the transformer for power rectifying in powering equipment, and signal demodulation. It can be used in many demodulation AM signals, and it can be used in signal peak detector, where to detect the peak of the incoming waveform. These are the very important applications of half-wave rectifier. So today what we have seen is, we have seen the working of half-wave rectifier, and we have seen the advantages, disadvantages of half-wave rectifier. I believe this video will be useful for you. Thank you, my dear students.